Welcome to More Learn, More Teach, where I attempt to simplify the complex. Today I'd like to talk to you about how time is going to affect value. So we're looking at the effects of time on value. We have a concept called annual percentage rate, APR, or annual percentage yield, APY. I will be using APR in my examples, but keep in mind that we could use APY or APR in any of this math. So the annual percentage rate is the change in value from the beginning of the year to the end of the year. So how much change in value occurred from the beginning of the year to the end of the year, that number divided by the value that you had at the beginning of the year. So it's the change in the value divided by what you started with. I can express that as APR is equal to delta V from n minus 1 to n over the value at n minus 1. Want to do it this way so that we treat n as the number of the end of the year. So if I went from year 0 to year 1, n would be 1. So it'd be the change from 0 to 1 divided by 1. All right? Hopefully that's not confusing, because it'll be an important concept going forward. I can define the change in value from the beginning of the year to the end of the year as the value that I end with minus the value that I started with. That's a definition of the change in value. Using this equation, I can say that the change in value is equal to the amount I started with at the beginning of the year multiplied by the APR. Very important that we understand this only covers 1 year. Only covers 1 year of change. This is only the change from the beginning of a year to the end of a year. All right, I can rearrange these two equations. Okay, so remember, they're equations, so all of these things are equal. This expression is equal to this expression. Therefore, if I added the value at the beginning of the year to both sides of this equation, I get the value at the end of the year is equal to the value at the beginning of the year plus the value of the beginning of the year multiplied by the APR. Another way to express this is in words. Value at the end of the year is equal to the value at the beginning of the year multiplied by 1 plus the APR. If I took this expression and I divided the value at the beginning of the year, I end up with 1 plus APR. All right, so let's say we have the case that I have a constant APR and I want to look at some future value compared to some initial value over several years. So how would we do that? If I look at this timeline, I have year 0, year 1, year 2, and year 3. Our equation is that the value at the end of the year is equal to the value at the beginning of the year multiplied by 1 plus the APR. So at year 0, I have whatever the value I start with is. At year 1, the value at year 1 from our equation is the value at year 0 multiplied by 1 plus the APR. All right, so now let's look into year 2. So the value change from here to here is going to be expressed with this expression. So we have the value at year 2 is equal to the value at year 1 multiplied by 1 plus the APR. Well, we know what the value at year 1 is relative to the value I started with overall. So if I substitute this expression for V1, I have that the value at year 2 is equal to the value at year 0 multiplied by 1 plus the APR, that whole quantity multiplied by 1 plus the APR. I can simplify this to express that the value at year 2 is equal to the value I started with overall multiplied by 1 plus the APR to the power of 2. Continuing this on, the value at year 3 is equal to the value at year 2 multiplied by 1 plus the APR. Substituting in the value at year 2, I get the value at year 3 is equal to the value at year 0 multiplied by 1 plus the APR to the power of 2, that whole quantity multiplied by 1 plus the APR. I can simplify that to the value at year 3 is equal to the value, so the value at year 3 is equal to the value at year 0 multiplied by 1 plus the APR to the power of 3. If I continue this on to some future n, I could say that the value at that future year, at n equal to n, at some future year, is equal to the value I start with multiplied by 1 plus the APR to the power of n. Now that we have determined that the value at the end of a year is equal to the value at the preceding year multiplied by 1 plus the APR, also equal to the initial value multiplied by 1 plus the APR raised to the power of n, I can also say that the ratio of the value at the end of the year divided by the value I start with is equal to 1 plus the APR raised to the power of n. So I want to introduce something called the rule of 72. Okay, so the rule of 72 is a thumb rule. It is an approximation. It's not an exact. Approximation is the rule of 72 says that if I take the time to double the value, that's about equal to the number 72 divided by the APR in percentage. Also, the APR needed to double the value is about equal to 72 divided by the number of years. Another way of expressing that is that the value at the end divided by the value in the beginning equals to 2. That is going to equal to 1 plus the APR quantity to the power of n, such that APR multiplied by number of years is about equal to 72. So let's see some examples of this. If the APR is 10%, if I take 72 divided by 10, I get 7.2. So the time to double in value is equal to 72 divided by the APR in percent. So 7.2 years, I should double the value. All right, so if I use my equation, the value at 7.2 years divided by the value of 0 is equal to 1 plus 10% divided by 100%. All of that to the power of 7.2. Plug that in the calculator, you get 1.99, which is about 2. All right, so 7.2 years wasn't good enough, so we want to get this done in 2 years. So if I say that I want to double my money in 2 years, what APR do I need? If I use the rule of 72, 72 divided by 2 is 36. So I need an APR of 36%. Running the numbers, the ratio of the value at year 2 divided by the value initial is equal to 1 plus 36% divided by 100% quantity squared, and that's going to be 1.85. It's about 2. So let's say I want to be more accurate than the rule of 72. I could, given the APR, find the number of years for a given ratio of final over initial. I could also, given the number of years, find the APR required to generate a ratio of final over initial. In both cases, I start with my base equation. I'm going to have to take the log of both sides. So take the log of both sides. I can take the natural log or the regular log, does not matter, because you're going to, whatever you choose though, that's what you're going to put in your calculator. So log is the easiest. Use log, both sides. That allows me to move this exponent. So now that I have log of this value, I can move the exponent of the argument of the log to the front of the log, property of logs. So the log of the ratio is equal to n times the log of 1 plus APR. I have to do that in both cases, both given the APR, finding the number of years, and given the number of years, find the APR. In both cases, I have to go to this step where I have to take the log to move that n over. All right, so now it's an algebra problem to solve for n in terms of APR for this one. So given the APR, find the number of years. Here's what I have. I divide both sides by this quantity, and I have the number of years is equal to log of the ratio of the final value over the initial value, that divided by the log of 1 plus APR. Again, this would work for natural logs. Doing it in log, in my opinion, is easier. On this side, given the number of years, find the APR. Again, I end up with taking the log of both sides, extracting the n from the exponent. Now I'm trying to manipulate this such that I'm finding the APR. So I'm going to divide both sides by n. So I have 1 over n over here, and I take the n out of here. The reason I want to do that is because I want to bring this back to the argument so that I end up with log of the ratio to the 1 over n power. Want to do that so that I can clear this log, right? So I take 10 to the power of to both sides to clear the log. If you had natural log, you would take e to the power of. But we did log, so 10 to the power of both sides. And I have the ratio of the final value over the initial value to the power of 1 over n is equal to 1 plus the APR. So the APR is equal to the ratio to the 1 over n power, that number minus 1. Remember, this is going to be in the terms of a fraction. If you want to get that into percentage, then you're going to have to multiply by 100% to convert that into a percentage. Thank you for watching my video. Please like and subscribe. If you have any questions that I can help you out with, I'd be happy to try and answer your questions. Send me an email at morelearnmoreteach@gmail.com.